Free Chipotle. I'll just be doling out Chipotle to everybody. That'll be good.
If they looked at the video, yeah, because then they'll come and be like, "Where's my Chipotle?"
It was a
I feel like I wouldn't
burrito.
even be motivated enough even by Chipotle to do this.
Oh my god. To what? Do the work you're supposed to do? So listen, I don't know if this is a real thing, but this pops up in several different calculus books. This whole like mailing packages things. Yeah. Girth is just a distance around the outside perimeter the whole way. So yeah. So look, they're telling us that it has a square end. So again, what we can change is the dimensions of the box for some reason. All right. So it's a square end. So whatever that is that, and then it also has a length, which I'm just going to call L. Okay? And this problem's telling us the sum of its length and its girth can only be 108 inches. And we want to mail the largest volume. Okay? So the equation we want to maximize, which is hopefully where you guys, did this, what do we want to maximize? What's the volume of this box? X squared L. Double XL. That's the size pants I buy. All right. Get it? Those are big. Whatever. Okay. The problem with this is there's too many variables again. So that's that whole like length plus girth thing. Has to equal 108. So we know 108. How do we write the sum of the length and the girth? Oh my goodness! Thank you, Lauren. It is L plus 4x.
When I got a weird number, I didn't know what to do with that. I think I got a negative number for mine. So.
That's what they're saying there. The length plus 4x's can only be 108.
Oh no, I got that the length
Okay.
would be 52.
52.
It's actually 36.
So we're going to do the same thing we do for all of these. We solve that equation. We're going to drop it into the volume equation over here. And that's going to reduce our independent variable count down to 1, which allows us to derive it. So the calculus behind this one's not really that complicated. The setup might have been a little weird, I guess, if you didn't know what girth was, but it's just 4x's. It's the distance around. If this was a cylinder, it would have been the circumference of the cylinder. I think that's the next one they ask. But anyway, before you derive this, you should simplify it down. So you're going to get 108x squared minus 4x cubed, and then we're going to derive it because we want to know where the minimum or the maximum volume is. So we derive it and we get 216x minus 12x squared. Did you get here, Lauren?
Yeah.
Good. So, and we're good with that? That's just the derivative. We want to know where there's at 0. And to find out where it's 0, we're going to factor it. So when x comes out of here, we can take a 6 out, right? Oh, we can take a 12 out, can't we? Yeah, we can take a 12 out. Because what's that? 6 times 36, so it's 18. And this is minus, took out a 12 and an x, so x equals 0. So our magic numbers, critical numbers, are 0 and 18. Okay with that? Then we're going to put a number line here. 0 is the smallest x could be anyway, and like realistically. 18 is our other critical number, and we're going to test this out here. Okay, if we plug a number less than 18 in, like 4. All right, we're plugging into our derivative right here. You get 12 times 4 times 18 minus 4. Positive or negative? It's a positive number. If you plug in a number bigger than 18, like 100, you get 12 times 100 times 18 minus 100. It's going to be negative, which means what's happening at 18? There's a maximum volume when x is 18. They specifically asked us what dimensions will give us the largest volume, so the dimensions are going to be, if you go back up to our picture, the dimensions are x equals 18, and if x is 18, L has to be, from down here, 108 minus 4 times 18. And 4 times 18 is what? 72? That's what L is. What is that? 36? Cool. And the units on that are inches. Cool.